Hello everyone, this is Oshini from Chinta.com. Today we will be doing a very interesting problem from Algebra. It is a factorization problem, but it has a very weird connection with an inequality, the AMGM inequality. If you are following this channel, you know that I love connections between different parts of mathematics. And this one is particularly interesting. So let's get started. The inequality that I have in mind is the AMGM inequality. And the factorization, well, this is the expression that we would like to factorize. A cube plus B cube plus C cube minus 3ABC. We would like to factorize this. The main idea, there are many ways to do this, but the main idea that we will be using is the Vieta's theorem. So in a moment, I will talk more about that. This video is created at Chinta.com. If you are following our channel, then you already know about it. If you are new, I invite you to subscribe and like our videos if you like mathematics. We have outstanding programs in mathematical Olympiads, ISI-CMI entrances. Check the link in the description for more details. So let's go to the solution of the problem. We would like to factorize A cube plus B cube plus C cube minus 3ABC. So what we do is we set up a polynomial. This is a strategy that is used in many problems. The polynomial is this. We have x cube minus a plus b plus c times x square plus ab plus bc plus ca times x minus a, b, c. This is my polynomial p of x. So the Vieta's theorem says that in any polynomial with the leading coefficient 1, so leading coefficient means the number that is multiplied to the highest power of x. Here that is 1. That's called the leading coefficient. So if the leading coefficient is 1, if leading coefficient is 1, then, well, in the case of a cubic equation, this is a cubic polynomial, the sum of roots with a negative sign is coefficient of x square. So the number that is multiplied to the sum or to x square is the sum of the three roots. It's a cubic equation. So by fundamental theorem of algebra, there are three roots, real or complex. Sum of them is multiplied to x square. Negative of sum of the roots is multiplied to x square. Similarly, plus product of roots taken two at a time, two at a time, is the coefficient of x. Coefficient of x. And finally, negative of product of all roots is the last number, the x free term. So the coefficient of x square, x to the power 0. Coefficient of x to the power 0. Power 0. Okay. So this is known as the Vieta's theorem. It's a very powerful result in elementary algebra. You should definitely know about it. Now, if you look at this polynomial that we have created, clearly the three roots are a, b, and c. That's how we set it up, right? That's how you set it up. The sum of the roots is a plus b plus c with a negative sign. The product of the roots taken two at a time, and the product of all three roots. So we have set this polynomial up in such a way that the roots are a, b, and c. Okay? So if I plug in a, it will give me 0. If I plug in b, it will give me 0. If I plug in c, it will give me 0. So let's do that. Let's plug in a, b, and c. So I'll copy this, paste it here. So in place of x, let's plug in a, right? So this is 0. Similarly, I'll plug in b, and b. So this is also 0. Finally, I'll plug in c. So the trick is to write the polynomial in such a way that a, b, c are automatically the three roots. Now let's add this up, add all of these up. So if I do that, I will get a cube plus b cube plus c cube minus, so here I have a plus b plus c common, and a squared plus b squared plus c squared. So that takes care of this column, right? And similarly, the other column, this one, I can take ab plus bc plus ca as common, bc plus ca as common, and I have a plus b plus c again. And finally, if I add all three of them, it is negative 3abc. It's equal to 0. Okay, so we exactly have what we need. It is a cube plus b cube plus c cube, which is this, minus 3abc is equal to this entire thing. So yeah, I can bring it to the other side. So I have a plus b plus c as common, and I'll have a squared plus b squared plus c squared minus ab minus bc minus ca. Okay, so that's absolutely fantastic. We have factorized a cube plus b cube plus c cube minus 3abc into two parts. Now the question is, how is this connected with the AMGM inequality with three variables? So here is the connection with AMGM. So if you are new to this channel, maybe you don't know what is AMGM. I'll tell you what it is. Basically, if you have three numbers, x, y, and z, then the arithmetic mean or AM is known as is actually equal to x plus y plus z divided by 3. Just the average of the three numbers. And the geometric mean is known as GM. This is the product of the three numbers raised to the power 1/3. So I'm just working with three numbers. We can do it for n numbers, but I'm just focusing on three numbers at the moment. And it's a very powerful theorem. It's a theorem that AM is greater than or equal to GM. By the way, X, Y, Z are positive. Works only for positive numbers. So AM is greater than or equal to GM. Let's say greater than or equal to. Okay, if you can plug in 0 as well. So anyway, AM is greater than or equal to GM. That's the claim. This is the claim. And for three variables, there is a surprising connection with this particular expression and this inequality. So how is that? Okay, let me just copy this here. Okay, so if you look into this part, I can easily write it like this. So this is half times 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. I just multiplied by a 2 and divided by a 2. Okay. So now, but this is equal to half times a square minus 2ab plus b square plus b square minus 2bc plus c square plus c square minus 2ca plus a square. Okay. So what is this? This is simply half times a minus b whole square, b minus c whole square, c minus a whole square. That means this is sum of squares, right? This is sum of squares. So what do we have then? Well, we have a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c times half times a minus b whole square plus b minus c whole square plus c minus a whole square. Right? So, if everything is positive or greater than or equal to 0, let's say, everything is greater than or equal to 0, then the left hand side is equal to something positive or greater than or equal to 0 times something greater than or equal to 0. Why? Because this is the sum of squares. Sum of square numbers is always 0 or more, right? If all of them are 0, then of course the sum of squares is 0, but it's either 0 or positive. So it's a property of real numbers that square numbers are always non-negative. So sum of square numbers is always non-negative. So what we just figured out is that this is positive or non-negative times non-negative, which means a cube plus b cube plus c cube minus 3abc is greater than or equal to 0 because it's non-negative times non-negative. Right? Okay, so how does that help? Well, I wanted to show, my goal was to show that if x, y, z are non-negative numbers, then x plus y plus z by 3 is greater than or equal to xyz raised to the power 1/3. So can you tell me, this is the last line of this proof. This is x times y times z. X times y times z. So xyz raised to the power 1/3. So can you tell me how these two are related? Why are these two things related? That's just one more line. Maybe you can tell me in the comment section. So I hope you like this video. Mathematics is a lot of fun, and one thing we should be always doing is to think outside the box. We have to look at problems for their own sake, for the beauty of the problems. Okay? Only then we will enjoy it. I hope you are enjoying mathematics. If you want to join our programs, check the link in the description. We have many beautiful programs in mathematical sciences, and I'm sure you will like it. Take care. I'll see you in the next one.